Hey everyone, I hope you're all doing well at home. This is just a quick video to explain to you a little bit about how different types of compounds dissolve in water. So before we start talking about dissolving, we need to just review a couple of things. So the first thing we need to review is what types of compounds we have. So there's two types of compounds that we're going to talk about dissolving in water. You'll notice that I don't have my notebook because I'm at home and not at school, and I don't have it with me, but you guys should have your notebooks with you. So I want you to go to page 79 and take notes along with me. So your page should look kind of like this, and then you'll just start writing with me what I'm writing. So we have ionic compounds, which are made of a metal and a non-metal, and hopefully you have your periodic table in your notes as well. Just a reminder, the metals are on the left side of the periodic table, so right here, and the non-metals are on the right. So everything to the right of this diagonal staircase line is a non-metal. And then just remember that hydrogen, even though it's over here with the metals, is a non-metal. So just remember that. So an ionic compound has both of them. A covalent compound is made up of just nonmetals. So let's first talk about how ionic compounds dissolve in water. And to do this, we're actually going to draw some pictures. So if you want to pause the video and get some like colored pencils or crayons, I'm going to use colored pens. That will make your drawing go a little bit better. So I'm going to draw kind of like a cup of water, and this is going to be before the compound dissolves. We're going to draw an arrow, and then we're going to draw after the compound dissolves. And we're going to kind of try and zoom into the molecular level. So the ionic compound that we're going to be talking about is table salt. So table salt is NaCl. So we've talked a little bit about NaCl before, and we are going to draw it in its crystal structure form. So to do that, I'm going to draw two green circles that are kind of diagonal from each other, and I'm going to make them blue. You can make these whatever color you want. Two blue circles. And we're going to say that the blue circle is Na plus, so sodium, and the green circle is Cl minus, so chloride ion. And then we're also going to draw, because this is a cup of water, we're going to draw some water molecules. So our water molecule, we're just going to draw two of them, is going to look like this. This is going to be the oxygen. So we're going to say the O is oxygen, and oxygen has what we call a partial negative charge. We show that with a little delta symbol is what that is. And our hydrogen in our water, it actually has a partial positive charge. That just means it doesn't have a full positive charge, but it's got a partial charge. So we have two water molecules here, just floating around in the water. Now, since water has a negative side, that's the oxygen side, and a positive side, it's going to be attracted to the sodium chloride. So in our after picture, we're going to draw our ions separated. So we're just going to draw our Cl ions kind of separated from each other, and our sodium ions also separated from each other. And then we're going to draw our water molecules attached to the sodium and the chloride. because the reason these sodium and chloride separate is that the water molecules come in, and when they see the sodium and the chloride, they are attracted, because we know that opposite charges attract. So the negative, the oxygen side of water, is going to be attracted to the positive sodium ion. So this water molecule is going to be kind of stuck to this sodium ion because the sodium ion is positive and the water is negative right there. Our hydrogen sides of water are going to be attracted to the negative chloride ions, again because the hydrogen is positive and the chloride is negative. So this is all just about opposite charges attract. So the positive side of water is attracted to the negative chloride ion, and the negative side of water is attracted to the positive sodium ion. And this is how salt dissolves. You'll notice that the salt is now broken up into ions, and that makes it conductive. So if you dissolve salt in water, that solution will conduct electricity. And this is why people say that water conducts electricity. Pure water by itself would not conduct electricity, but water that we encounter almost always has some kind of ionic compound dissolved in it, some kind of mineral dissolved in it, so it conducts electricity. So to explain this, just underneath we're going to write ionic compounds break into ions when they dissolve. Okay, now really quickly, let's talk about covalent compounds. So an example of a covalent compound is sugar. So sugar does something different than salt does when it dissolves. So we're going to draw a cup again and put some water in it. And again, we'll do before and after. Okay, so sugar molecules are covalent, which means they're not made of ions. So we're going to draw our sugar molecules, instead of being a crystal structure, we're just going to draw them as kind of long ovals. So we're going to make our long oval the sugar. And even though it's not ionic, it does have a positive side and a negative side because it's a polar compound. And then again, we're going to have the red be our oxygen and the black be our hydrogen. So when we put sugar into water, let's say we just have a couple of sugar molecules in the water. So we'll say this is 2 sugar molecules. These are not going to break apart into ions. These molecules are going to stay together. However, the 2 molecules will separate from each other. So after it dissolves, I guess we should draw our water molecules first. So let's draw 2 water molecules. So after it dissolves, we're going to have 2 sugar molecules, or however many sugar molecules you dissolved, floating around in your solution. The negative side of the water will be attracted to the positive side of the sugar molecule, and the positive side of the water molecule will be attracted to the negative side of the sugar molecule. So you'll notice the covalent compound, it did not break into positive and negative ions. So we're going to write down covalent compounds do not break into ions when they dissolve. And this is important because if covalent compounds dissolve in water, that does not make the water conductive. The water won't conduct electricity if sugar is dissolved. If sugar is the only thing dissolved in the water, and you stick a light bulb with some wires in there and try and connect the circuit, it would light up in salt water, but it would not light up in sugar water. And that's because salt is ionic, and so when it dissolves, it conducts electricity because it breaks into ions. But sugar is covalent, so it will not conduct electricity when it dissolves because it doesn't break into ions. So that's the main idea for today. There's one more video that you guys can watch to learn a little bit more about this, and then there's just some questions that you'll need to answer. I know I went really fast, so let me know if you have questions. There's a part of the assignment in the quiz that asks you if you have any questions. So be sure to ask any questions there, and hopefully you're all doing well. Have a good day.